So we're going to talk a little bit about exact versus approximate, which is often a little bit counterintuitive for students. If you punch the number, the square root of 2, into a calculator, what you will get is 1.41421, and it'll actually go on about 8 to 10 places depending on the calculator. The question is, what is more exact, the square root of 2 or what the calculator spits out, 1.41421 and a handful of more decimal places? Well, if you wanted to find 1.4 on the ruler, what you would do is you would look between 1 and 2, and what you would end up doing is you would go 4/10 of the way across, so it would be just before 1.5. In other words, 1.4 is the same as 1 and 4/10. Now, if you want to be a little bit more exact, you would have to go to 1.41, right? And 1.41 is 1 and 41/100ths. So what that means is we would actually have to take this ruler, and instead of breaking the centimeter down into 10 parts, you'd have to break it down into 100 parts and find where 41 out of 100 is, which isn't an impossible idea. It certainly could be done. Let's take one more position. We go 1.414, which would be the same as 1 and 414,000ths. And so what we would need to do to find that on a ruler is we would need to break the centimeter, for example, down into 1,000 parts, and you would have to find out where 414 is out of 1,000. I guess that would be okay if we had to stop there, but the problem is that when you put the square root of 2 into a calculator, you get 1.41421, and then you get a 3 and a 5 and then a 6 and a 2, and then the calculator stops. But not because that's the end of the decimal, because it stops because how many places is it going to give you? What are you going to do with all those places? So, to understand, the square root of 2 is what's called an irrational number. So let's write that down. It's irrational, I guess, in the sense that a person who doesn't make a whole lot of sense is irrational. An irrational number in a lot of ways doesn't make a lot of sense. It goes on forever and it doesn't repeat and it doesn't terminate. So here's the paradox. If every time you add another decimal place, you have to go a little bit further into your ruler and split it up into that many more places. First we split it up into 10 parts, then 100 parts, then 1,000 parts, then would be 10,000, and so on and so forth. But if the number never ends, if the decimal points go on and on and on, then we're just going to have to keep breaking up into more and more parts, and it'll be a never-ending process, which creates kind of a paradox. Ultimately, no matter what you do, the square root of 2 will always be much more exact than whatever you get out of your calculator, even if you take it to 100 or 1,000 or 1,000,000 places. So, if you're ever asked for an exact answer, you're going to leave it in a radical form, because in radical form, it's more exact than any decimal value you get out when you put it in a calculator. Now, obviously, if you're given something like the square root of 9, the square root of 9 is a perfect square, and you're going to end up taking that out completely, and it won't be a radical anymore. But if you get the square root of 10, and you punch that into your calculator, and you get 3.16, whatever you get, 3.16, and then it looks like a 2, what you're going to find is the square root of 10 is more exact than the 3.16, whatever you get out of your calculator. So it's just important that you understand the difference between exact and approximate, and it's also important that you understand that a radical that cannot be simplified any further and is not a perfect square, like the square root 2 or the square root of 15 or anything like that, that is going to be an irrational number. So hope this video made sense. If not, you can ask me some questions on it.